Hello, beautiful people. And everyone else, too. I'm DJ the Deconstructor, and you have entered a deconstruction zone. You're looking at a picture of Rick Joyner. Rick has his own internet show, Morningstar TV. Rick thinks he knows the second law of thermodynamics. Because he thinks he knows about the second law of thermodynamics, he has taken it upon himself to tell everyone about it. But it turns out he really doesn't have a clue. When Rick talks about the second law of thermodynamics, he doesn't mention entropy. He doesn't mention enthalpy. He doesn't even show the math behind the second law. If you were to watch the entire show, he would go on to say how the second law of thermodynamics actually disproves the theory of evolution. Honestly, I don't care if people try to discredit evolution. What I don't like is when they base their arguments on badly misunderstood science. So, today we are going to look at the second law of thermodynamics. I'm going to let Rick give his take on the second law of thermodynamics, and then I'll be showing you what the second law of thermodynamics really is. Before we get started, please take a moment to like, share, subscribe, and hit the notification bell. Doing those things helps my channel grow. Also, please comment. Your comments are always welcome. I've put a link to my Patreon site in the show description. If you like what I do, consider becoming a Patreon supporter. It will help me continue to produce educational content. Now it's time to sit back, relax, and enjoy this episode of Deconstruction Zone as we jump into the second law of thermodynamics.
But the second law of thermodynamics is, once you understand it, help you to understand a lot of things that are going on in the world. And it's a very simple law. It basically says that everything, this is everything, that includes everything, will trend towards disorder unless it is acted upon by an outside intelligent source.
I have to stop here. It's clear that Rick doesn't have a grasp of the second law of thermodynamics. I do agree that the second law applies to everything, but only insomuch as it applies to everything that is affected by energy, specifically heat energy. But here is a major disagreement. Rick said everything will trend toward disorder unless it is acted on by an outside, intelligent source. Let's do a quick web search for the second law of thermodynamics, just to see if anything comes back that's even close to what Rick said. I normally don't recommend going to Wikipedia for research, but in this instance, I'm going to break my own rule because that's where a lot of people go for information. According to Wikipedia, the second law of thermodynamics is a physical law based on universal experience concerning heat and energy interconversions. One simple statement of the law is that heat always moves from hotter objects to colder objects, or downhill, unless energy is supplied to reverse the direction of heat flow. Another definition is, not all heat energy can be converted into work in a cyclic process. The second law of thermodynamics in other versions establishes the concept of entropy as a physical property of a thermodynamic system. It can be used to predict whether processes are forbidden, despite obeying the requirement of conservation of energy as expressed in the first law of thermodynamics, and provides necessary criteria for spontaneous processes. Let's ignore for a moment that what you just heard from Wikipedia may sound a little like a word salad. What is interesting about this Wikipedia article is that nowhere is there anything about systems being acted on by an outside source, let alone an intelligent one. So what's happened here? Why is Rick talking about outside sources? I can only guess, but I think he's conflating some things he's heard, and he's come up with his own version of the second law of thermodynamics. I do know of a law that uses the phrase, outside force. It's Newton's first law of motion. An object at rest tends to stay at rest unless acted upon by an outside force. Rick said, everything will trend toward disorder unless it is acted on by an outside intelligent source. If you take the time to read several articles about the second law of thermodynamics, you will see a variety of definitions. But most textbooks are going to say something about the relationship between enthalpy and entropy. Enthalpy is heat energy and entropy is the degree of disorder in a system. Remember what Rick said, that everything will trend toward disorder unless it is acted on by an outside intelligent source. It is true that the second law talks about disorder, but it's also talking about energy. The second law defines a relationship between energy and disorder. Enthalpy and entropy are directly proportional. As enthalpy, energy, increases, entropy or the amount of disorder also increases. It's kind of like the time when I tried to fix my lawn mower. I pushed my mower into the driveway and had to disconnect the fuel line and drain the gas. I found an old tuna tin in the trash bin and put the gasoline in the tin. While I was working on the mower, a cat came up and drank some of the gas from the tin. That cat let out a howl and ran off at high speed. It zigzagged around the yard, it ran up a tree and back down, ran in circles, and came right back to the mower and stopped. Then it just fell over. No, it wasn't dead, it just ran out of gas. Enthalpy and entropy are like that. In my story, the gas provided energy to the cat. The cat ran in a disorderly fashion. When the energy was gone, the disorder was gone too. Whether or not disorder is in a system is strictly a function of the amount of energy within the system.
And that means everything in nature will trend towards disorder if someone doesn't come in and do it.
No, once again, that's not right. Not everything in nature needs someone to come in and impose order on the system to prevent chaos. Imagine you have a seed. Plant the seed in the soil. What happens in a day, 2 days, 3 days, a week? The seed sprouts. Roots start to form. A stem forms. Eventually, a flower forms. The plant shows a high degree of order. It has a vascular system to bring moisture from the soil up to the leaves and the rest of the plant. Its flower has petals that are neatly arranged and organized. There is a high degree of order in that plant, and no human intelligence was required to direct the order. No person kept the plant from being chaotic.
Now, laws are different from theories. And, a law has been proven to the point where they say this is fact. This is no longer a theory. That's why it's called the second law of thermodynamics.
There is a common misconception about what constitutes a scientific law versus a scientific theory. Both a scientific law and a scientific theory have an equal amount of acceptance in the scientific community and carry an equal amount of weight or authority. Do you think that the germ theory of disease is any less accepted than the law of gravity? Is the first law of motion more authoritative than atomic theory? No, of course not. Both laws and theories have been tested and proven to be correct, time after time. There is no real difference. So why is one called a law and another called a theory? The difference is math. A law can be described mathematically. A theory cannot be summarized in a mathematical formula. If you Google the definition of the law of gravity, you will come up with something that looks like this. The mathematical formula you are seeing is showing that force is equal to the gravitational constant times the product of the masses of two objects, divided by the square of the distance between the objects. There is definitely math involved here. Compare that with defining the germ theory of disease. If you look up a definition, you will not find any math involved. How could you possibly translate the idea that disease is caused by microorganisms into a mathematical formula? It can't be done. The idea that germs cause disease is called a theory, and the laws of thermodynamics are called laws because math. Here is the math we call the second law of thermodynamics. The T in the formula stands for temperature and not for time. The amount of time that passes is not important to the formula. The formula demonstrates that the change in entropy, delta S, is equal to the heat divided by the ending temperature minus the heat divided by the starting temperature. You will also notice that there is nothing in the formula about anyone causing this change. Imagine that you have a cooler or an ice chest. Inside of the chest, on one end, you place a small block of ice. On the opposite end, you place a jar of boiling water. When you close the lid, you now have a closed system. Heat is not escaping. The only heat exchange is between the boiling water and the ice. What happens inside the chest? It's pretty obvious that the heat will move from the jar of water to the block of ice. We leave the system alone for a period of time and come back to open the lid and observe our results. The water is now much cooler and the block of ice has melted. The heat has reached equilibrium and the water in the jar is the same temperature as the water that was once the block of ice. The changes in heat in our jar of water and our block of ice is our change in enthalpy. There was also a change in entropy. The water was in a highly disordered state. On the molecular level, the molecules of water were moving rapidly in all directions. As the water cooled, the disorder was diminished. The block of ice also underwent a change in entropy. Before heat was introduced into the ice, the water molecules were held firmly in place. They were vibrating, but they could not move past and around each other. As the heat increased, the water molecules broke free and were able to move more freely. This relationship is described perfectly by the second law of thermodynamics.
There has never been, ever, an observed event that trended from disorder to order without being acted on by an outside intelligent source.
At this point, Rick is doubling down on his version of the second law of thermodynamics. He offers as proof of the validity of his version of the law an assertion that there has never been an observed event that trended from disorder to order without being acted on by an outside intelligent source. I like his assertion because it is falsifiable. If we can find an event that is clearly an example of something that trends from disorder to order without being acted on by an outside, intelligent source, then we have demonstrated that his assertion is false. Let's give it a go. Look at this beautiful snowflake. Notice the high degree of order. Snowflakes start as clouds of water vapor. What causes snowflakes to form? Is it an outside, intelligent source? The water in clouds is disordered. The molecules of water are chaotic, moving in random directions. As the temperature drops, the water condenses and begins to freeze. The freezing droplets form ice crystals we call snowflakes. With no outside intervention, the disordered water vapor becomes highly ordered snowflakes. Here is another picture. This is copper wire under a microscope. A little silver nitrate solution has been placed on the copper wire. Spontaneously, with no intervention, the disordered molecules of silver nitrate give up their silver ions and deposit them on the wire. As silver ions deposit, they become silver atoms, and they arrange themselves into orderly crystals with no intelligent intervention. Finally, here is a picture of 2022's Hurricane Ian. Notice the degree of organization in the storm. The more organized the eye of the hurricane, the more violent the storm. Hurricane Ian began as a tropical storm. Notice the lack of organization in the tropical storm. What intelligent, outside source increased the amount of order in the storm to make it into a hurricane? Our world and the entire universe is filled with examples of disorder becoming order. It has been observed, and we will continue to observe it. And it is all described perfectly by the laws of thermodynamics.
The whole universe, believe it or not, regardless of the order it's now, but it's trending towards disorder.
Rick has upped his claim. He now asserts that the entire universe is trending toward disorder. Remember that entropy is disorder. The second law of thermodynamics tells us that the only way for disorder to increase is for enthalpy to increase. There are only three possibilities. 1. The universe is heating up and subsequently the amount of disorder increases. 2. The universe is cooling off and the amount of disorder is decreasing. 3. The universe is at equilibrium. It is neither heating or cooling and the amount of order remains constant. It is fairly simple to figure out which one is correct. All we need to do is consider a few facts. 1. The first law of thermodynamics shows that energy can neither be created or destroyed. Because of this, the amount of energy in the universe is constant. 2. The universe is expanding. It's an accepted fact and I encourage you to look it up if you want more information. The implications of a static amount of energy in an expanding universe means that the amount of energy per cubic meter of space is decreasing. It's decreasing not because there is less energy in the universe, but because there are an ever-increasing number of cubic meters in the universe. That means the universe is cooling off. As the universe cools, the amount of disorder decreases. The universe is becoming less chaotic and more ordered.
Every galaxy is breaking apart. Every star is going to burn out, implode, explode. Everything is trending towards chaos.
No. What Rick is saying is just not true. I'm not saying Rick is lying. I think Rick believes what he is saying. But he's still wrong. He probably does believe that every galaxy is breaking apart. But thankfully, that's not the case. Galaxies are held together by gravity. Every object within a galaxy is held in their relative positions by gravitational forces. What does it take to overcome gravity? Energy. Energy would have to be added to the motion of that body for it to break free of its galaxy. That's just not happening. He is correct when he says every star is going to burn out. This is called the heat death of the universe. But that is not a state of chaos. It is a state of very low energy per cubic meter of space, and therefore a state of low entropy. I'm going to stop here. I don't want to subject you to any more of this. I'd like to offer one piece of advice to Rick. In the future, if you ever want to talk about anything science-related, please seek the advice of an intelligent outside source. Thank you for watching. I appreciate all of my faithful viewers. By the way, this is Sunshine. Sunshine wants you to like, subscribe, hit the notification bell, and visit my Patreon site. If you don't, Sunshine will know, and Sunshine will come to your home and deconstruct something. Until next time, this is DJ the Deconstructor, wishing you happy sciencing.